Assalamualaikum warahmatullahi wabarakatuh. And good day. My name is ALIF ABNI ADNAN. This is the video presentation for the 9th International Conference on Education, Business, Islamic, and Technology 2025 that will be held on 28 until 29 December 2025 at ALIF Hotel, Kota Baru, Kelantan, Malaysia. So the research title that I will be presenting today is Study of Turmeric Drying and Different Uses of Modular Thermal Energy Storage. So these are the other participants or contributors in this research, which is Dr. Sheikh Muhammad Firas, Sheikh Abdul Nasir, and Dr. Hamid Yusuf. So I will be covering on the content. So these are the content of my presentation. So I will be covering introduction, methodology, data and discussion, lastly conclusion on my research. So for the introduction, I will be explaining on the drying process. So the drying is one of the oldest techniques of preserving agricultural products like fruit, vegetables, cotton, and others by removing the moisture content of the product, which is to prevent decay and spoilage of the products. However, the solar dryers are significantly only during daylight and have limited working hours. Therefore, thermal energy storage systems were introduced to extend the capacity of the drying process during night, especially during the night time. On the other hand, solid-state thermal energy materials like sand have not extensively investigated for thermal energy storage application. So we come up with the study of sand as the medium of the thermal energy storage. For the methodology, these are the setup of the turmeric drying process. So we have the EAQ cataloger, thermocouple wire, aluminum box, sand, which is glass sand, turmeric, drying net, and drying net frame. So the sand that has been used is the silica sand as a thermal energy storage medium for this turmeric drying. Then the thicknesses has been varied from 10 mm until 30 mm, as you can see in this picture. And the analysis of temperature variation of the sand has been investigated. And also the weight of the turmeric has been measured using the wager, and then the initial weight is 100 grams and the final weight will be below than 20 grams. So here are the results of the experiment. For the weight against time for the turmeric has been plotted. So these are the graphs. As you can see, the weight of the turmeric increases linearly with the drying time hours. This phenomenon is because the moisture content inside the turmeric freezes as the drying time increases due to the evaporation process. The environment temperature increases with the increase of the time, thus increasing the drying rate of the turmeric drying process. The greater the thickness of silica sand, the greater the losses of moisture content inside the turmeric. The turmeric drying time from 8 a.m. to 12 p.m. is lower than from 1 p.m. to 5 p.m. This is likely due to the heat energy is not being absorbed enough to the sand. The turmeric drying time of 1 p.m. until 5 p.m. is faster compared to the other time hours. This sense is due to the high temperature sub sandbox that absorbs heat from the sun. From 5 p.m. until 9 p.m. The drying becomes slower than at other time intervals because the sand loses heat and there isn't enough heat energy to remove the moisture from the turmeric. The 50 millimeter thickness has a slow dry rate from 9 m to 5 m compared to the other drying conditions. This slowdown is due to the larger area of silica sand needed to store the heat energy. However, the drying rate 50 millimeter becomes faster than others from 1 p.m. to 5 p.m. since the production process in silica sand turmeric drying has occurred rapidly. Furthermore, heat is transferred from the air to the turmeric by simultaneously transporting moisture from the interior of the solid turmeric to the surface, where it is removed by the moving a stream through the convection process. Next, these are the graph for the temperature ratio, which is temperature of sand over the ambient temperature against the time in hours. So overall, the temperature ratio increases from 8 m to 12 p.m. and the highest temperature is expected to be at 2 p.m. and begin to decrease till 9 p.m. This increase is due to the highest amount of energy from sun. The 50 millimeter thickness receives a lower temperature ratio from 8 a.m. to 12 p.m. since there's a larger area and needs to store the heat from sun. However, from 9 p.m. to 9, sorry, from 1 p.m. to 9 p.m., the temperature ratio becomes the highest among all time intervals because the heat has been fully stored in the thermal energy storage. Higher temperatures inside the sandbox can expedite the drying process as compared to the outside temperature. The study indicates the previous study indicates the drying process worked the sandbox would be significantly more effective than the than drying the turmeric under normal conditions, normal outside conditions. This finding is further supported by recent research which demonstrated that the temperature within the solar diet exceeded that of the external environment. This indicates that the temperature inside the sandbox is elevated relative to the outside temperature, which is attributable to the sand's capacity to retain heat energy as a sensible heat solid thermally material. So, as the conclusion, the value of the temperature ratio, which is temperature sand over the ambient temperature, against time, and also the way against time for the turmeric has been obtained through experimental studies. So the different thicknesses of silica sand inside the thermal energy storage has been analyzed and also compared with the low thermal energy storage. Therefore, we can conclude that the simple sand with average of 10 millimeter size of diameter has the ability to store the heat energy, which can accelerate the thermonuclear process compared to the condition without the thermal energy storage. However, some modification can be made by the composition of the silver set as the thermal energy storage to give more efficient system and get the best composition which can hasten the drying process of the turmeric. That's all for me. Thank you for listening.